So this is lesson number 77, Algebra 2, Advanced Radical Equations and Multiple Radicals. Alright, if you remember, which sometimes it's hard to remember some of this stuff because sometimes it's just so long ago, when you'd have a radical like this, and you want to get rid of the square root, you would square this and square this. And then you'd get x minus 1 equals 16 and x equals 17, and you'd be done. Okay, notice what happened here at the very beginning. When we want to get rid of a radical, what you have learned to do is square both sides. Okay? And that's what you do when the number that's right here is a 2, which when there isn't an index number in there, it's an assumed 2. You assume that there's a 2 in there. You don't have to write it every time. Alright, so that's why you square it, is because there's a 2 there. What if there was something other than a 2 in there? Well, then you would not square both sides. Alright, so let's just jump into this first example here. It gives us a cubed root. And it's x cubed plus 6x squared minus 4 minus x minus 2 equals 0. Alright, so first of all we're going to isolate the radical. We're going to get just this part on the left side of the equal sign before we do anything else. So we're going to write it as cubed root of x cubed plus 6. And we're going to move the other stuff over to the other side by adding it, adding the x to both sides, adding the 2 to both sides. Alright, now that we've done that, now we can, instead of square both sides, what do you think we're going to do? We're going to cube both sides. And when we cube both sides, that takes off the root sign. But now we have to do the FOIL method to that twice. So we're going to have to takes x plus 2 times x plus 2 times x plus 2. Alright, so we're going to do the FOIL method here. And we get x squared plus 4x plus 4. And then we're going to multiply that by x plus 2. So let's go ahead and multiply this times this. This times this. Okay. Now we're going to do this times this. And this times this. And then we're going to multiply this times the x. And this times 2. So see, it gets to be quite the mess here. So now what I'm going to do is I'm going to combine like terms. So I just took care of that and that and that. And that. Okay, so this right here is x plus 2, the quantity cubed. Alright, so I'm going to see if I can get rid of a bunch of the stuff here that's in my way. Okay, so I'm just going to do that. How's that? So this here is the answer of the x plus 2, the quantity cubed. Alright, so I've got this whole thing to solve. Alright, one of the things that's nice is when I have this here and this here that are the same, I can just make them go away. I have a 6x squared here and a 6x squared there that I can make go away. And I'm left with negative 4 equals 12x plus 8. Okay, subtract 8 from both sides. And x equals negative 1. All that mess just to get negative 1 for an answer. Okay, so that's pretty much it for that first part of the lesson. So let's go on to the next part as soon as I kind of erase my scribbles here. And it's called multiple radicals. Alright, so let's look at one. I'm not going to use a K, I'm going to use X just because K's are stupid. And then I write one. Okay. Alright, so how do I solve when I have multiple radicals? Well, I get one of the radicals by itself on one side of the equal sign. It doesn't matter which one. We'll just take the first one. Okay, so make that line longer. Equals square root of x minus 1. So I added that to both sides, subtracted that from both sides. Alright, so in order to get rid of this radical, we square it, and we square the other side. So we get x minus 5 equals, and we have to do the FOIL method to that because that's actually that. Alright, so I do the first numbers. Square root of x times the square root of x is the square root of x squared, which is just x. Then I do the outside. So I get negative 1 square root of x. Then I do the inside. Then I do the last. So x minus 2 square root of x plus 1. So that's what goes okay. So let's get rid of all this work that I did here so that I have room to continue on if I need it. Alright, so what I just erased was the square root of x minus 1 squared. I used the FOIL method and that gave me this. Alright, so let's go ahead and get rid of stuff. What we're doing here now is, see, we got rid of one of the radicals, but we still have one here, so we have to do the same thing. We have to isolate it. We have to get everything else away from it. So I'm going to move all of this to the left side. So let's move the x. So that gives me negative 5 because that disappears and that disappears. And I'm going to subtract 1 from both sides. That leaves me that. So this is negative 6 equals negative 2 square root of x. Divide by negative 2, divide by negative 2 gives me 3 equals the square root of x. Square both sides, and I get 9 equals x. Okay? That's it. Okay, let's do another one. Example 77.3. They use a letter S. I am not going to use an S because that'll look like a 5 and I'll mess it up. So I'm going to use an X again. Okay, so what I'm going to do is I'm going to move this over to this side. Again, isolating one of the radicals. It doesn't matter which one it is, but okay, then I square both sides, and this becomes x minus 8. That's the easy part. Then I have to take 2 minus square root of x times 2 minus square root of x. I need to use the FOIL method because I'm squaring it here. And that gives me, let's do this in yellow, 2 times 2, my first one's is 4. Then my outside, 2 and negative x. Then my inside, then my last. So I have 4 minus 4 square root of x plus x. So 4 minus 4 square root of x plus x. Alright, so this stuff can all go away. I'm all done with it. Work's over. Don't erase your work though, because I need to see where you got stuff. Alright, now you see how this can get really messy? So I'm trying to teach you how to be neat. You know, I got a lot of room to talk in my explanation here, but when I actually do work, I try to be neat on my homework so that other people can get it. Alright, so now I need to clear that right hand side of everything except the radical. So I'm going to subtract 4 from both sides. I'm going to subtract x from both sides. Okay, and that'll go away. X minus x is 0, so actually I have negative 12 equals negative 4 square root of x. Divide by negative 4, divide by negative 4, those go away. This becomes a 3. Square both sides, and x equals 9. Okay, so you get 9 for an answer, and I didn't do this on the last one, but you need to take your answer and plug it in to the original equation to make sure it works. Alright, so our original equation, I'm going to put it down here at the bottom so that I can move it up in just a minute. I don't know why I put an 8 there, or a 6. It's early in the morning. Okay, so there's my original equation, and let's move everything up here. Move our 9 up, that's our answer, and we're going to plug it into our original equation. So 9 minus 8 is 1, so square root of 1 is actually 1. Square root of 9 is 3. And I get an answer that 4 equals 2. Alright, so it did not check. When that happens, when you do a problem like that, and when you put it in there to check, and you get something that's untrue, then there is no answer. Because 9 is the right answer, but when you put it back in, it does not work. And a lot of times it doesn't work, or all the time it doesn't work, when you're dealing with radicals, is because you're dealing with radicals. Okay? It's called an you don't have to write this down, this is a free one. An extraneous root. It means that there is a number in there that when you do the algebra, it all works fine and dandy, but when you plug it in and check it, it does not work, and it has to do with the square root. So we will get into why that's the case later, but at this point, just remember to put your answers back into the original equation and check it when you have a square root there to make sure that it's the right answer. Okay, so that's it for lesson 77.